Okay, so hello everyone, and this is a recording for the Generative Deep Learning course. So we are recording our StyleGAN v2 running right now, and we want to show that it is running and printing some loss, generated loss, and discriminated loss, and also see how we are generating images right away. So we use StyleGAN v2 because it requires less number of images, and also the quality of the images are fairly well compared to other models. And over here we use StyleGAN v2 from public GitHub repository because it uses TensorFlow v2. The original one used TensorFlow v1, so we were not able to implement that. So we used the TensorFlow v2 implementation. While this is running, as you can see here, because it takes time, so I'll just show you the results that we got. So we realized that around 1 million is like our best results, around 1 million number of images. As you can see here, the images are very nice and clear. Some of them do not represent dogs because that's like mixing different styles. Because we're generating a random latent code in the latent space, so we might not necessarily find the dog in that specific latent code. We also did check mixing, and let's see the mixing at around, let's say for random 950. As you can see here, we got some representation of the color of this breed over here. We got some shape over here. If you look, for example, at 1 million, where's 1 million? At around 1 million, you can see, for example, over here, we got the color, maybe the eyes. Over here, we got the nose. Yeah, so here at 1 million, yeah, so this is basically the generated output. Now I'll show you the loss. Over here. So as you can see here, this is the loss curve. Excuse us for this, and we have here like the labels, but they are in a little bit dark, so I don't know if you can see them. But we started, because our loss, we were not able to save the earlier losses, so we started at around 150,000. That like mini batch, and that's around where we started to save the losses. Before that, the losses were kind of similar pattern to this. After a certain point, it started to become very bad, and that's because maybe the discriminator was very good and the generator was not able to improve its performance. If you go back and see, before we move on, let's see, this is the original data set. For example, you can open here. These are some images from the original data set. And if you go back and go to the preprocessed, these are preprocessed images that were fed into our model. These images, we got them from Kaggle, and as you can see here, for example, this is some generation. We saved these like because we were running it multiple times, so the best ones we were saving. As you can see, for example, this one, we were able to get the shape, or not the shape, the color from both of them, and maybe the eyes from here to generate this. So this is the mixing. Another good output that we got was this one, for example. These are not the only ones, of course. We had so many good outputs, but like we just showcasing. Here we have a dog, and we got the color from the first one, and we got the shape and from both of them, and we got, for example, the face from this one. So we did basically take the styles from both the breeds and generate a new one. Let's go back and see if the code has printed anything for us. As you can see here, we got the mini batch. Yeah, okay, it's running, as you can see, and we got the generator loss, we got the discriminator loss, we got the generator loss, discriminator loss. So let's stop this for now, since we already showed that it works, and let's generate some images to show you that it is generating images. So here we're just taking the checkpoints and we're generating based on these checkpoints. For example, let's see, if you go here, and refresh this, you can see some of the images here are generated seconds ago. These are the early stages, that's why you're not going to see any good output. But if we keep it running for a while, it's going to generate all the way to 2 million checkpoint, 2,660,000. So this is going to take a while, of course. So, but we proved that it's working. Let's go to 280, for example, 280, to see that it is improving actually, and that this is actually generated by our code. 280,000. This one, for example. As you can see, it improved, and at around 1 million is where our images are like the best. I'll keep it running for a while. Let's see where this has reached. Okay, in the meantime, I'll show you another thing. So this code is used to generate just a single image. So there's no need to run this code again. This code is to save the generator, and then we used it to do GAN inversion. So as I mentioned, that we are trying to have the user insert breed 1 image and breed 2 image, and then we're supposed to generate a breed, the third image, which has style from the first 2 breeds. So the way we want to approach that is through a method called GAN inversion. So it takes in the image of the first breed and the image of the second breed, and then it tries to find the latent code in that generator, or in that style GAN generator, and give us images that are very like represent the original image as much as possible. We tried to approach this using mean square error, and we did not really achieve very good results. And as you can see here, this code, it takes in the image from FID1 PNG, and it does the inversion and saves it in inversion. So if I go over here, so it takes in from FID1.png. So this could be a real image or generated image, but just for testing we use this image. So we want our generator to generate an image that represents this. So through GAN inversion, we are supposed to get an image that represents, but we did not get that. And that is maybe because of the loss that we're using and some parameters that we used. Since we're using mean square error, maybe that might have not worked well. Maybe we were supposed to implement a different architecture or incorporate it in the StyleGAN v2 architecture. Maybe we're supposed to use perceptual loss, but due to time constraints, we're not able to do that. So this is actually a future work that we would like to work on. But my colleague is going to actually show another method of using GAN inversion in the next part of this video. But let's go back, and this is for the GAN inversion, basically this part. And let's go back to the generating images. Okay, so let's check 1 million. Let's go and check 1 million. These are random images, so it will not be the same. So at around 1 million over here, we get, as you can see, we get dog images, and they're pretty good images actually, and yeah, that's expected at around 1 million. And these are different from what I shown you earlier because it's saved 1 minute ago. And also let's go to mistake checkpoints, and let's check the 1 million checkpoint. 1 million checkpoint is around here. Yeah. So as you can see here, okay, this is actually not bad. We got the nose from here. We got the eyes kind of from both of them. We got the shape of like this white area over here. So we were able to do the mixing. So basically our code is able to do the mixing. The only part that's missing is allowing the user to insert a breed 1 and breed 2, and we generate the resulting breed. Now let's show the last part, which is our loss. Just because we were not able to save the previous losses, so we had to just store it in a notebook just so that we avoid rerunning this, because this takes a really long time to run. So here we take the loss.txt file and we generate a loss.curve.png. So if I run this, as you can see, I go to project and I go to here. As you can see, this was generated seconds ago. So here's my loss curve. And I think I've shown you this earlier, but here's the discriminator loss, here's the generator loss. The generator was good over here, but it got worse over here. And that is, as I mentioned, that the discriminator got really good. So I think I'm done with my part. So now I'll hand it over to my colleague. Thank you so much.
Okay, so I'll be talking to you about GAN inversion, the GAN inversion aspect of our project. GAN inversion is basically when you take an image and try to find its latent space, or find the latent space where your generator can generate the same image. What we're trying to do is, generate dogs. We want to use our generator, but right now we're kind of struggling with that. We've managed to change it to, sorry, we've managed to change it to work on our data set over here, but we still haven't managed to make it work on our uh, pre-trained model or on our generator. That's because they're using PyTorch over here, but we're using Keras, and we just have to save it in a different way. Yeah. So yeah, we'll just run it for now, and should work hopefully. So yeah, the model it's using is not the one we want to use, but it is using the data set we want to use. Uh, let's see if there are any results yet. Okay, not here. Logs, images, train. Let's see. Yeah, and even later, I might come back a little later and show you what it starts looking like, because actually I think it's in a different file. Maybe it's in tests. It shows you. Okay, now. So a little later, it'll start showing you images of a face being generated for some reason. Well, not for some reason. That's because the generator they're using is made for faces, or pre-trained on faces, rather than on dogs. And we're trying to generate dogs from it. So it's of course, freaking out a little bit. But yeah, hopefully we'll be able to change it to work with our generator instead of the face generator, and then we'll probably have, you know, GAN inversion working.
Hello everyone. So I'll be explaining about our usage of relational autoencoders to compare different architectures to the style GAN that we use for our project. So for this relational autoencoder, the dataset that we use is similar to the one that we use for style GAN, which is the around 9,000 images of dogs. However, for this model, we had to resize the images of dogs to 28 by 28 in order to lower the load on the graphics cards, because we were planning to run it for more than 1,000 epochs, and the kernel usually disconnect by around 500 epochs or something when we have the resolution high. When we have it as 28 by 28, it disconnects at around 2,000 epochs. So when I run the code, firstly, we will try to obtain the images from our dataset folder, and then we will display one image. And you can see that the quality of the images will be reduced when we try to resize the images, which will, of course, have some effect on the output. So here you can see the training process of the variation autoencoders. You can see the loss gradually decreasing. And this process should stay for ideally for around 5,000 epochs. However, we were only able to have it run for 1,000 epochs before the kernel got disconnected, and you can see the output that we obtained here. So you can see these images are the output. You can see the resolution being low quality. However, you can see that there are hands of dogs from here. For example, you can see here the ears, the eyes,